Okay, right now you're writing the essential question. Everybody's writing that down. Okay. Okay. We got it? So first thing we're going to talk about in relation to infinite limits is asymptotes. Did you guys all grab a calculator today? Yeah. If you didn't grab your calculator, make sure you got it. Okay? So, because the first one is looking at the direction things are going here. So we need to determine the limit as x approaches 2 from the left and the right by completing the table. So what I need you guys to do is you're going to everybody type this function into your f equals, okay, and in your scratch pad of your calculator.
This is limit again, right? Spell it.
What?
It is limit again?
Yeah, it's still limits. Okay. This is the last couple of sections of limit. Last couple of notes on limits, though.
Where's your flies at, Ruthie?
I don't have it up. Is it there that bad today? There was one particularly annoying one in here. The rest of them had disappeared. Okay, everybody got it typed in? Shh, I'll see if I can get mine up, but mine takes forever to turn on. Okay, so what you're going to do now is you're going to go back, exit to the scratch pad screen, right? And you're going to hit var and 1.5. var, choose F, and type in 1.5. Does that make sense? We've done that before, right? Okay, and then do it again and type in 1.9. And I want you to write those values down in your notes. So everybody's going to take a minute and do that. You don't need to plug in the 2, because the 2 is going to be 0 or undefined, right? This is like your first homework assignment. You're right.
If this was a test, I passed. If this was a test, I get a 6 on the AP exam.
You don't want to get a 6.
Is that bad?
That's too much, yeah.
Oh.
I think there is one number that you get when like if you use profanity or something. But
Yes. I thought they don't read it if you scratch it out.
if you scratch it out,
They can't read it.
true, they don't read it if you cross it out.
Yeah.
But if you don't cross it out, then
Oh my.
yes. But some people aren't that smart, even though they are in AP classes. All right, so we had 3. I'm going to do one just to make sure. So if you don't know what you're doing, we have done this before, but if you don't know what you're doing, I'm demoing it right now here. X minus 2. And then I'm going to go back to my scratch pad and go var f1 of 1.5. And hit enter. Okay? And you're going to keep going until you get your chart filled out. So I'll give you about another 30 seconds to fill out your chart. Okay, let's check it. All right. So let's see what you ended up with. So you tell me, what did we get for 1 at 1.5?
-6, 6.
Good, and 1.9. And 1.99. And 1.999. Good, and 2 we wouldn't have gotten anything because it's undefined, right?
Correct.
That's why we're trying to look at the limit as it approaches that value. All right, 2.001. 3,000 and 2.01. 300 and 2.1. 30 and 2.5. What you're really looking at, though, because I normally would have come in from this direction. As we're coming at it from the left side here, what number are we getting closer and closer and closer to? No, on the y's, sorry. Well, it says negative 3,000. Notice how small of a value we added, but it kept making this huge jump. So ultimately, where is that going to end up? What's the biggest number we could end up at? Negative infinity, good. But coming at it from this direction here, where am I ending up? Infinity. Positive infinity. So we can determine this numerically. That's a really weird looking infinity. We can determine this numerically with the chart just like we did before when we first started doing limits, okay? If the number's getting significantly small or significantly big, we say it's going to either negative or positive infinity, all right? And again, we weren't adding that much on there. There was very, very insignificant values and the number jumped really, really big. The y value did, okay? All right, so infinite limits. We're not going to look at all of this because I don't do delta epsilon proofs anymore. Basically what this is saying, the official definition, okay, is let f be a function that's defined at every real number in some open interval containing c. The statement f of x approaches, or at limit as x approaches c of f of x equals infinity, means that there's some value m that's greater than 0. Yeah, we're not even going to go through it. Don't worry about it. I don't know why I even have it in there.
We don't have it.
Oh, you don't have it?
No.
Nice, it's not in your notes. Great, move on. Okay. For some reason, I still had it in the PowerPoint. Okay. So determine whether f of x approaches infinity or negative infinity as x approaches. What is x approaching? 1 from the left and the right. So we have to write that notation in there. So I want you to practice writing your limit notation. So limit as x approaches 1 from the left, and you're going to just name the function f of x, right? Because that's what it says right there. And then we're going to find the limit as x approaches 1 from the right of f of x. No, you don't need to plug it in. Okay, because we're going to do this one, because the last one we did numerically, now we're going to do this graphically. Okay? So, because remember, there's the 3 ways, right? Numerically, graphically, analytically. Okay? All right, so here's our 1. As the graph is coming at it from the left side, what's the y value going to? Good. As we're coming at the graph from the right side of 1, where's the graph going to? Infinity. Perfect. All right, so then we're going to do the same thing over here, limit. We're going to have some of those on the test, okay? That's what this unit is about, believe it or not, is limits. So we're going to get some easy ones like that on the test. Okay? Some. We still have to do some of the other ones. But this chapter so far hasn't been extremely difficult. Okay? All right. Looking at B, as we're approaching from the left, where is it the graph going to? Infinity. As we're approaching from the right, where's the graph going to? Infinity again. Okay? All right. I want you guys on your own. We're approaching the same number. I want you to practice your notation, and everybody try C and D on their own. I'll give you about a minute to write down your notation and practice the limit. Shh. To yourselves. Okay, let's check it. So, as on part C, as we're approaching 1 from the left side, where is it going to? Infinity. What about from the right side? Perfect, good. And as we're on D, as we're going to the left side, we're going to? And the right side? Negative infinity. Good, yes.
So if you write the notation down wrong, limit x approaches 1, would we be knocked down?
If you didn't tell me... So if it doesn't look like that, you mean? I might ding you a little on this test, but it is important to make sure your notation is correct. Okay? And the only reason I'm dinging you is to teach you now versus you getting it wrong on the AP test, right? So you got it. The notation, you guys, in this class is almost more important than learning the math sometimes.
You're just looking out for this, right?
Yeah, I am. I'm trying to get you to do it now versus and practice it right from the beginning versus not getting it until the very end. Okay? All right, vertical asymptotes. We have talked about these already, okay, a little bit. If f approaches infinity or negative infinity as x approaches c from the left to the right, then the line x equals c is a vertical asymptote. So basically, remember what's left in the denominator is a vertical asymptote. Okay? So find all the vertical asymptotes, if any, of the graph of the function. So does anything cancel? No. All you do is you set that denominator equal to 0. I'm being really lazy about it right there. Okay? And so what? I would divide by 2, and I'm left with x plus 1 equals 0. So x equals what? Negative 1. There's your vertical asymptote. Doesn't get a whole lot easier than that, right? Set the denominator equal to 0. Divide by it. Okay? And then do your algebra 1, right? That's what we did. Okay, well, I can't do anything about that now. You had me for advanced algebra 2, so I know you know that, okay? All right, what do I have to do? Well, does anything factor to begin with? Does the numerator factor?
X plus 1, x minus 1.
The bottom is x plus 1, x minus 1. Is the top x plus 1 minus 1? No, so you can't factor the numerator, so I'm just going to take that denominator and set it equal to 0. There's no point in doing the factoring if I can't cancel anything, right? Because this is pretty easy to do without the factoring. All right, so x squared ends up equaling what? 1. And then how do I undo the square? And what do we put in front? Plus or minus. You guys are trained really well. All right, square root of x plus 1, or square root of 1 is? 1. So x equals plus or minus 1. All right. I know, that's what. Okay, check this one out. So we got to find vertical asymptotes. We know it's a cotangent. We know the cotangent graph because we did go over this last year. Looks like that, and we know there are asymptotes. Okay. I'm going to give you the interval. So add this in. That we're only going to go between negative 2 pi and 2 pi. Actually, I shouldn't say that. I should say 0 and 2 pi. Why? Okay, so the reason I'm restricting it is because, remember, trig functions are cyclic, right? They go around and around. If I don't restrict it, that means I have to add in the next coterminal angle and the next one and the next one and the next one, right? All right, I don't have a denominator, but I could create a denominator. Think about cotangent in terms of sine and cosine. What would I get? Good.
I'm trying to get some.
Okay, so now in order to decide where the asymptotes are, we take the denominator and set it equal to 0. So I need to know on my unit circle, where is the sine 0? What radian measures? Okay, so at 2 pi and at pi and technically at 0 would be my asymptotes in that interval, right? What did I do? Okay. Do you understand the cotangent? Okay, so my vertical asymptotes, remember, you guys, shh. My vertical asymptotes is set the denominator equal to 0. Okay? And then remember to reverse the trig. We got to go look at the x values on there. And then we read the radian measures, which is 0 and 2 pi off of our unit circle and pi off of that side.
So if we have a problem like this, would you restrict it at 0 and 2 pi?
I would, and that's okay with me. All right. The other thing you could see is that they say that it is pi n as in the answer book. Okay. I don't know if they will put the restriction on it or not. I didn't look that closely at the homework. Okay. So I'm okay if you just do the first revolution around. Okay. All right. Let's switch to, because I want to keep going a little bit because that was really short. So we might as well keep going and get the other ones done.